Hello everyone, my name is Rahul and welcome back to my channel DevOps Force. Today we are going to learn what are monolith architecture versus microservice architecture and how does big companies implement these concepts, and also why does a DevOps engineer should learn these concepts. Along with this, we will see at last that which architecture should be chosen and when. So let's jump to the explanation. So imagine we are building a food delivery app. Let's call it Swiggy Food App. Swiggy needs a bunch of things to work. It needs users to be able to log in. It needs to show restaurant menus. Users need to place orders and payments need to go through. After that, drivers will be assigned and notifications will go out. Now in a monolith, all of this lives in one place. This is our application and one box, one deployable unit, and everything lives inside here. Now let me show you what's actually inside. So you can see there are various modules inside our app. So inside our one big app, we have all of these modules. An auth module handling the authentication, whether a user is allowed to make a call or not. And restaurant listings will have the restaurants nearby who are serving food currently. Orders module will process orders based on your selection. Once order is processed, payments module will prompt you to make the payment. And once the payment is done, you receive a notification through notifications module. And tracking module lets you see how much time will the rider take to reach your home, similar to what you have seen in other food apps. Now here's the thing, these are not separate applications, these are just folders packaged inside one code base. In Java, what you have done, you would have done that com.swiggy.auth, okay, will make a call to com.swiggy.orders module, then it will make a call to payments module, all in one project, all running in the same process. Now, when the order modules need to talk to the payment module, it's just a direct function call, right? No network, no HTTP request, no timeout possible, just payment service receives request from order module instantly. Now, below our application, we have one database. One database means all modules read from and write to the same database. So you can see all of these modules are making read and write call to one database only. The users table, the orders table, payments table, and restaurants table all sitting together in one schema. And how do we deploy this? We package the entire thing in a .jar file or a Docker image, and we deploy this artifact to the production server. Correct? One artifact, one deployment, the whole application is delivered as one unit. Now let me ask you, is this bad? Is this wrong? No, absolutely not. When Swiggy has 2 developers and 100 users, this is perfect. Everything is in one place. Debugging is simple, one log file, one process, and the database is one query away from anything. Deployment is only one command, and this works beautifully until it doesn't. Now the question is, where does the monolith architecture starts hurting? So let me show you the problem. So problem one is deployment coupling. Now imagine it's Thursday. The payment team has a critical bug fix ready. Okay? And one line changed in the payment module has to go out today. But here's the problem. Look at the order module. It is half finished. The orders team accidentally merged an incomplete feature this morning, which means on Thursday only, and it's not ready to deliver. But in a monolith, remember, this is one box. You can't deploy payment without deploying order. And they are the same artifact, okay, existing inside one big box. So what do? Either you delay the payment fix and wait for orders to be ready, or you ship broken orders code to production. Neither is good, right? One team's problem is now every team's problem. Now comes the second problem, which is scaling coupling. Okay, what does that mean? Basically, let's take an example over here and understand what does scaling coupling actually mean. Let's say it's lunch hour and orders are going crazy. Thousands of requests per minute hitting the order module, right? You can see high traffic is there and thousands of requests are hitting per minute to the order module. Now we need to scale it, right? Because our app will not be able to take this much load. So we obviously need to scale it. And in a monolith, how do we scale? We spin up more copies, isn't it? And the whole application is copied and we have scaled it into 3 instances. Now, these 3 instances will look at what we actually scaled, right? We scaled auth, which isn't under load. We scaled notifications, right? Which is completely idle. And we scaled tracking, which nobody is using it right now. We had to scale all of it just to get more order processing capacity. So in order to scale this order module, what we did, we made 3 instances of this particular app and we did a horizontal scaling, right? But since this is one big application, we have to scale all of these modules. And the auth module is also scaled, the notification module is also scaled, tracking module, which is idle. So all of this were not meant to scale because it was working fine, right? Now that's expensive, isn't it? Which is not required. The auth module, restaurant module, we scaled them as well. So of course there will be a cost and we have to bear it. So this is wasteful. Now comes third problem with monolith architecture, where one crash, everything goes down. The review model has a memory leak, slowly eating memory, let's say. Okay, what does memory leak means? Memory leak means it is consuming a lot of memory from the disk and is not giving chance to other modules to consume any memory. So let's say your review module takes a lot of memory to process the review, right? And for that, since all of our modules are using one process only, one memory only, in that case, review is consuming a lot of memory and it is not giving chance to other modules to consume any of the memory, right? After a few hours, the whole JVM process runs out of memory and crashes. Since this is our Java app, right? So the whole JVM process runs and it is out of memory and it crashes, right? So we have scaled it using the load balancer, and when it crashed, the entire app is down, right? Not just reviews, everything. Orders down, payments down, auth down, the whole app is dead because of a bug in a feature that had nothing to do with the critical path. No isolation, one bad module takes everyone with it, right? So to resolve this, we will understand what is microservices next. To solve the problem, whatever we have faced in monolith architecture, we will introduce microservices architecture. And we are going to use same app, but this time a different architecture. Instead of one big box, each module become its own independent box and its own service. You see, we have multiple modules over here, right? And it becomes its own service rather than residing into a one big box. So each box is its own application, its own repository, right? So everyone will have own repository. And look, order service is using Golang, notification service is using Python, and you can use whatever language makes sense for that specific job. Because sometimes, let's say for notification, uh, Python is more reliable rather than any other programming languages. And for restaurant service, let's say it is a backend and you have a faith in Java as the backend, so you code that in Java. Similarly, you can use any programming language based on your requirement and what is the feasibility. Correct? So each one is using different language. Now, each service has its own database And that's what you call a microservice architecture. This is one of the most important rule of microservices, that each service owns its data. Order service cannot directly query payment service database. They talk through APIs, not through shared tables. Why? Because if they shared a database and the payment team changed a column name, the order service breaks. You have coupled them through the database, and it solves the whole problem which was coming from monolith. Now, how do these services talk to each other? So there are two ways. First is synchronous communication, which means making a direct HTTP call, right? You can see over here in this example that when a user places an order, the order service needs to verify they are logged in, and it makes an HTTP call to auth service, right? And checks whether is this token valid or not. And then the auth service responds that yeah, this is valid, and order service continues. So this is synchronous communication, where order service waits for the response. It is simple and direct. But there's a risk. What if auth service is slow? Order service is slow. And what if auth service is down and order service can't process orders? They are directly dependent on each other's availability. So the next way for the communication is asynchronous communications, which means event-driven communication via message queues. So we understood that if any of the service over here is low or is down, then we will obviously face an issue. To resolve that, there is a second way, we call it asynchronous communication, where uh, event-driven communication is provided via message queues. And there is a tool called Kafka. Okay, so think of it as a news board. So Kafka is a news board. Okay, service post messages here, right? And other services read those messages when they are ready. So over here we are understanding the concept of asynchronous communication, where Kafka message broker acts as a news board, and all of the services post their message in this particular board. Okay, and other services read those messages when they are ready. Correct? So let's move ahead and let's see over here what is happening right now. So when an order is placed, an order service publishes one event. Okay, let's say your order is placed, your order ID is 4821 and the user is 99 and the total amount is 240 rupees. So it doesn't call payment service directly, right? It doesn't know payment service exists. It just posts that event on the Kafka board and moves on immediately. And payment service is subscribed to order.placed events. It picks it up, charges the card, notification service is already subscribed, and it picks it up, sends the confirmation email. Now what if notification service is down for 10 minutes? Okay, so order still gets placed, payments still go through. When notification service comes back, it reads the events it missed from the queue and sends all the emails. Nobody will lost an email. The failure was completely contained, and that's called loose coupling. It is not tightly coupled, where any of the service is not relying on each other. Rather than what they are doing is they are posting their events to the Kafka board, right? And once the event is posted, the other service, let's say the order service posted an event and the payment service has received that message that order has placed an event in the Kafka board, and Kafka will send a message, queue that message to the payment service. Payment service will receive that message and will act accordingly. And this communication will be obviously channeled through Kafka board. Correct? And that is what we call loose coupling, or services are independent. A failure in one will not pull down the others, right? You see notification is crashed over here, but order and your payments are being processed. Once the notification module will be up, you will obviously receive the notifications, and any of your messages which are queued earlier will not be left out, right? Now let's see how deployment works now in microservices architecture. We saw in monolith architecture that one entire app was packaged, right? And it was called one deployable unit, and it was then converted into a .jar file in case of Java application, or a Docker image, and then it was pushed, the artifact was pushed to the production server, where the entire thing along with the auth, the payment, the notification, the tracking, everything was published as a one deployable unit, right? But in microservices, let's say payment service has a bug fix, right? So in microservices, they build their Docker image, push it, deploy it, done. 30 seconds only, right? Now order service still has that half finished feature. The same example we have took in monolith architecture, we are taking it right now. Okay, so payment service has a bug fix, and the bug is fixed, and they have built the Docker image, pushed it, and deployed it. It is done in 30 seconds, and no one is relying on any of the other services, right? Why? Because they are acting as an independent service, not relying on each other, not even making any changes, or affecting, or making an impact to other services. They are one independent resource, and they can act independently, where they can be also packaged independently and deployed. Now let's move ahead and see that when the payment service had a bug fix, order service still has that half finished feature. It doesn't matter. They are completely separate deployments, right? Payment team doesn't wait for anyone. Okay. And you will think now that what about scaling? So let's say in lunch hour, if huge traffic hits order service, scale it to 3 instances. Everything else stays at one, and you are paying for exactly what you are scaling, nothing extra. You see, what in the lunch hour we were seeing a lot of traffic in the order service, right? So we have scaled it to 3 instances over here, but payment service remains one only, right? So behind this box, you can see there are three other boxes where we have scaled the order service only, but payment service remains one. So we have saved the cost, right? But that's not it. The real cost of microservices is, and this is where I want to be really honest with you, microservices isn't free. It comes with real costs. Let me show you what your infrastructure actually looks like now. And you have auth service, order service, payment service, and similarly you have other modules as well, right? So this is what your infrastructure actually looks like. So look at what you now have to manage. Before any feature is built, you need all of this working. API gateway, so your mobile app has one entry point. Okay. Service discovery, so services can find each other. Distributed tracing, so you can follow one request across 6 services when something breaks. Centralized logging, so you are not reading 6 different log streams. Kubernetes to orchestrate all of these containers, and Kafka for async communication. In a monolith, none of this exists. One process, one log, and one deployment. This is real infrastructure complexity, real cost, and it also comes with real learning curve. And debugging, in the monolith, one trace tells you everything. But in microservices, that same user request touches 6 services. Okay, so in microservices, tracing becomes complex, right? Whereas in monolith, it's only one trace which we have to follow. But in microservices, the same user request is touching all of these services. It will go one by one to each of the service and make a call, right? If something breaks somewhere in this chain, you need correlation IDs in every log, distributed traces, and you are reading 6 different log streams simultaneously, correct? Just to find what is the problem. This is why microservice needs mature engineering practices. It's not a beginner architecture. Now, let's see why DevOps engineers should learn these concepts. Your application architecture directly determines what will be your operational steps for an application from development to deployment end to end, right? It determines your deployment strategy, how complex your pipeline is going to be, what monitoring setup you are going to implement for your architecture, your strategy to implement logging system, and how will you handle system failures. And at last, what are the safety mechanisms, or you can say rollback strategies you are going to implement for your application to work. Now, first comes the monolith architecture. Okay, why should we learn this? Right? Your monolith application will produce a single deployment artifact which is easier to handle and deploy. Right? Next, your CI/CD pipeline will look simple and not too complex. You will create a system where you will have centralized logging and tracing. The bug fixes will be easier to debug and your infrastructure setup will be simple and it will bear low cost. Right? Now, let's see why DevOps engineer must understand monolith architecture. So, first point is enterprise legacy platforms. For example, a company using their application from past 20 or maybe 30 years and don't want to migrate it to microservice architecture because they don't want to disturb the current running status of that particular platform, or the cost to migrate is way bigger than the feasibility, right? The next point is internal business applications. So, for example, the company has created an application where only the internal employees of the company are meant to utilize that, right? Let's say your internal team is using time punching system, or your insider portal where you fill where you will find every useful applications like payroll, leave tracker, or reimbursement system, etc. So these are called internal business applications where the internal team of the company is utilizing or using these platforms or these applications, where you don't need a complex microservice architecture. The monolith architecture will also work and it will work very uh, efficiently, right? Now, third comes early stage MVPs or startups, right? So, for an early startup to think directly implementing microservice architecture will be a huge pressure to them in terms of cost, workforce, and experience. So, they may not have a big budget, right? They may not have experienced engineers who can implement microservice architecture, because microservice architecture is very complex and mature engineers are only like, capable to implement that system, right? So the workforce may be also low and as compared to big companies. That is why early stage startups does not go with microservice architecture, rather they use monolith at first. Now the last is admin dashboards and tooling. Like I said, some of the application doesn't need to implement microservice architecture due to complexity or the cost it comes with. And also monolith apps are highly secured, right? With this, we will move ahead with the next one, which is why DevOps engineer must understand microservices. So the first point is independent deployments. In our example, we have seen how microservice apps deploys independently, right? And the next point is service level scaling. We have also seen this one where we have a particular service that needs to be scaled, and then only that service will be scaled not the entire modules, right? So the module which was getting high requests or high traffic, only that will be scaled, and other modules will not be scaled. They will remain one or whatever the number is required. With this, we will reduce the cost. Now, next comes your distributed monitoring, right? Microservice have distributed monitoring, which helps to track the logs or traces from a particular service. But this can go complex. You have seen this, right? Now comes the next point where we see container orchestration. So deploying your application in Kubernetes is highly scalable, which is why microservice architecture always depend on Kubernetes to deploy their applications, right? Now comes event-driven system integration. We have seen how we can introduce Kafka for event-driven communication between services and how they will not impact the running service, or if any of the other non-dependent service, which will not be impacted in case of one is down or maybe one is slow. Like we saw, when notification module is down, then also we were able to place an order and the payment was being made, right? Next comes observability changes in microservices. We have seen this one. In the first point, we can see that distributed tracing infrastructure is need to set up in microservices. For this, we can use tools like Jaeger or OpenTelemetry. Then comes your centralized logging platforms. Like you can use Elk or Fluentd to track your traces and do indexing of your logs or errors. Then comes metrics aggregation across the cluster, which means your Kubernetes cluster, and you can use Prometheus to scrape the data from the application, right? And the service dependency and topology tracking, which means we can also define what all services are dependent on each other and in what way. Next comes CI/CD pipeline impact. So obviously, monolith pipelines will have a single deployment pipeline, right? It will have only one single deployment triggered by the code commits. It will build the entire application into one massive artifact. We have seen this one in the example, and it is simpler to handle, but the builds are slow and times limit release the frequency, right? In microservices pipelines, multiple independent services can trigger separately. Let's say your order module will have a pipeline, then your payment will have another pipeline, then auth will have another pipeline, and it will run independently, right? It requires complex version tagging because we have multiple iterations of the upgradation or the update of our development code. So we will have to tag those, right? So that we can release multiple versions of our application. And we also have backward compatibility checks and also the advanced deployment strategies like Canary, Blue Green, and AB, right? Next comes your scaling strategy impact. So monolith scaling means you have to scale one entire application and horizontally. We have seen this, that our app was horizontally scaled and it was behind a load balancer, right? And if the reporting module requires more CPU, you must replicate the entire application and the code base, right? You've seen this one. The entire application or the code base was replicated into 3 instances behind a load balancer, and it came with a huge cost. Whereas what microservices scaling offers, it scales only busy services independently. And we have seen that we can also scale the payment service pods during a sale without touching the inventory service. So this is an example, right? Next comes your reliability and failure handling differences. Now, in monolith, we have system-wide failures. If one module or one service is down, we have to take care of all the services because they are interconnected and they are tightly coupled, right? But in microservices, we have service isolated failures. What does that mean? Our microservice architecture is loosely coupled, right? and even a container is crashed, let's say the order module is crashed, then also um, we have other modules which are performing well, so we can fix that particular order module only, and we don't have to take care of other modules. So in this way, failures are isolated in microservice architecture, right? And in monolith, if one goes down, then the entire application goes down, but this is not the case for microservices. Next come why DevOps engineer must learn both architectures. Okay, so in industry, the reality is some of the legacy and internal systems still run securely on monoliths, right? Let's say a company is using an application or a platform from a way back, and they are dependent on that, and they don't want to make any changes to this, or maybe they are using their internal application which they want to make it secure, right? So in this case, monolith is the one, and we have also seen that the startups are also using this. So both are relevant to the use case, right? It's not like monolith is bad or it is not performing good, right? It depends on the use case that which architecture is meant to be chosen. If an application is complex, needs to be scaled on a huge level, and the application is very big, then only we should use microservice architecture. And we should also take care that the monolith architecture should be used only in small engineering teams, right? We have limited infrastructure budgets, we have simple domain logic and early stage product validation. Let's say you are going to create a new product. So for that early stage validation, you should first implement the monolith, and as you scale, you should go ahead with hiring new engineers, mature engineers, right? You should introduce DevOps practices, the culture, and a better system where you do continuous improvement, and then only you move ahead with the microservice architecture. And when DevOps teams prefer microservice architecture, let's understand this. So large teams deploying independently is one of the use case where microservice architecture is used. We need our application to scale highly, right? And we have low friction releases. Then also we use microservice architecture, and also we have Kubernetes based infrastructure. Then also we have to use microservice because Kubernetes setup is very complex, and sometimes it can go hard to uh, new engineers or beginner engineers, whether they need to implement the entire infra setup of the Kubernetes. Infra setup means the cluster setup along with the control plane and the data plane, and also they need to handle the infra residing the Kubernetes cluster. Let's say your horizontal scaling, your vertical scaling, and other aspects like your elk stack. So all of these setup is need to be done in the Kubernetes cluster. This can go complex. Along with this, you need to deploy your application as well, right? Now comes the event driven processing platforms. Like I said, the big products or the big applications which require event driven processing. And event driven mean we need to use asynchronous communication, and all the modules are not dependent on each other. In that case, microservice architecture is used. So the industry rule says start with a monolith, move to microservices, and when scaling requires, then only you should go with microservice. Other than that, for an early stage, do the validation with monolith architecture. With this, we have finished this lecture, and if you like this video, subscribe to my channel, and we'll see in the next one.